Hello everyone, welcome to my channel Hypermesh Basic to Advanced. So to have a bit of a background about my channel, in this channel I make videos related to FE and Hypermesh. So if you are interested in these topics, kindly consider subscribing to get regular updates, correct? And if you're already a viewer and not yet subscribed, kindly consider subscribing as it motivates me to make more videos, correct? Okay, so moving on to today's topic. So in today's video, we'll be discussing drop test using LSDyna. Okay, so first of all, what is drop test and where is it used? Correct. So what is drop test? So in drop test, we are dropping some object onto a rigid object, correct, and observing its behavior, observing the stress generated, observing the damage, the displacement observed on the less rigid object, correct. So for example, if you can see on my screen, so I have a blue floor here, right? So on this floor, I'll be dropping a ball here. If you can see this yellow color sphere, correct? So this will be the ball. So this blue color floor, it's rigid, okay? And this ball is elastic. So when we are dropping this ball on this floor, we'll observe what are the stresses generated on this ball, okay? So basically that is drop test. So where is this used? So drop test is basically you can use it in for devices, correct? So like you have phones. So suppose you have to make a durable phone with a durable chassis, correct? So you do drop test. So you do drop test for that. You have some devices, industry level grade devices, medical devices. Okay. Then for logistics, packing. For all these things, you do generally drop test, correct? Okay. So uh, this is all for drop test. So to start with the video, so I already have a model as I showed you. So in this model, we have a floor. Okay, as you can see, this is a rigid floor, and on this we'll be dropping a ball, a sphere, yellow color, which is made of elastic material. So I've already made both these, as you can see, and I have named them floor and tennis ball. Okay, as you can see here, correct. So next we have the mesh, correct. We have the mesh ready. So next what we need to do, so we need to create a curve. Okay, so before creating a curve, I just wanted to tell you, I forgot this. So this is basically a free fall condition, correct. So in this what I've done is I have assigned a gravity vector, gravity, to this ball, correct. So if you can see here, I have made this curve here. If you can see the data points, so you have 9.8, 9.8, 9.8, correct. So this is basically gravity. So I made a curve with gravity, right, and I have named it gravity curve, correct, and I've assigned it to a load collector, correct, and that load collector I have assigned it in the y direction. If you can see here, so basically I have made a load collector named load body. Okay, its card image is also load body to see, correct, and in that, in the y direction, in the load collector ID, I have put the gravity curve. Why in the y direction? Because if you can see on my screen here, the ball will be displaced along the y direction. If you can see here, correct. So I have made the gravity curve. I have assigned the data points there and I have referenced it here under the load collector, correct. So we have the mesh, we have the curve, right, for defining the load collector, and we have defined the load collector. Next, so next we need to define contact between the ball and the floor, correct. So this contact I have defined as a surface to surface contact, right, because it's both surfaces are touching, correct. If you can see here, right, so you, as you can see the card image, it's surface to surface, correct. And in the slave ID, I have kept the ball as the slave and floor as the master. Okay, so this is for the contact. So we have the mesh, we have the load collector, we have the contact, correct. So next what, So next we'll define the material and the properties, correct? So material and properties also I have already defined. I'll just show you. So we have the ball material here, correct? So as I told you before, I've selected elastic material for the ball, correct? So if you can see, it's matte elastic. Okay, so card image is matte L1 and the values are as follows. Okay, you can try some other values if you wish according to your choice, and you can just check the variation in the results. Okay, then I have defined the floor material, if you can see here, correct? So this is rigid material as I told before. Okay, so this floor is rigid, ball is elastic, and for the floor I have defined the values as you can see on the screen. Just in case if you want to see these values in details, you can just go to my post on this topic. I'll put it in the description. Okay, and you can just check out the values in detail there. Fine. Okay, so we have the meshed model, we have the curve, we have referenced it in the load collector, we have defined the load collector, we have defined the contact, we have defined the material. Next is property. So for this I have used a common property since I have meshed both of these using shell elements. Okay, so the card image, if you can see, is section shell, correct? And the values I have used are as follows. So again, these values you can just go and check in the website. Okay, so I don't usually tell these values in the video because the video gets too long and people might drop off in between. So I'll just brief the process here, and if you want to check the values I've used, you can just go on to my website and check it there, or you can use a value according to your needs. Okay, okay, so mesh is there, load collector is there, contact is there, material is there, property is there, correct? Okay, so correct. Next we need to define the cards. So what are these cards? So we'll define a termination card to define the end time. Here end time I have used as 20. You can put something of your choice. You can make it more, you can make it less. It all depends on your choice, correct? Okay, so we have defined everything now. So next what we'll do, we'll go to export. If you can see here, this red arrow, if you can see here, we'll go to export. Okay, and we'll export the file type as LSDyna template R10, correct? And we'll select the location where we want to export, and we'll export the .k file, correct? So LSDyna exports as .k file. Okay, so once you have done that, you need to open the LSDyna solver, correct? So I'll just open that. So if you can see my screen, I've already opened the LSDyna solver, correct? So here in the input you have to select the .k file, if you can see here, correct? And then it will reference here, and you have to click this play button, and then it will start to solve. So I've already solved it. If you can see here, the status here, it's showing finished, normal termination. Okay, and just in case there is some error, okay, then it will become red here. Okay, but there was no error, it ran fine, so it's green here. Okay, so we'll move on to see the results. So if you can see my screen now, so this is basically the Hyperview window where we can check the results, correct? So I have already opened the model, if you can see. So I have selected the result type as stress, and it's one message stress. Okay, I'll just click on apply. Okay, and then we'll click on play. So if you can see, as the animation plays, there's a change in stress in the ball, correct? If you can see here, and you can see the legends here, correct? So basically the stress is changing as the ball is moving along the y direction, correct, after hitting the floor, correct? Next we'll check the displacement. Okay, so we'll just click on apply, and we'll just play the animation. Just zoom out a bit. Okay, okay, if you can see how it's going, correct? Just slow it a bit. can see how it is going. Okay, we'll just see the acceleration part, or we'll just see the internal energy part just in case. Okay, we'll see the internal energy, how it's changing here. We'll just see how it's going. Okay, so basically that is how you do a drop test. Okay, it's pretty straightforward. Okay, and you can just select what all you want and you can check it out here. Correct. So basically you can check the displacement, acceleration, velocity, stress. Stress is the main factor we check here, if it's damaging the product or whatever the object is falling. Okay. Okay, so I think this was pretty short and simple and straightforward video. So I hope you got to learn something new. And just in case if you want to put some extra value in the curve, right? So suppose you are not using a free fall, you are throwing it, correct? So there can be a case where you can be throwing the ball instead of it being in a free fall. So in that case you just need to change the values in that curve and you can observe the change in results. Okay. Okay, so this is all for this video, and I hope you got to learn something new. I'll try to make more videos on new topics, correct? And I just wanted to inform, if anyone is interested, I have one more channel related to finance. If any one of you is into finance apart from these technical things, you can check out my finance website. I don't have a YouTube channel related to that, but I have a website. So that also I'll link in the description, just in case if anyone wants to see, they can see it. Okay, so this is all for this video. Hope you got to learn something new, and see you all in the next video. Thank you, and don't forget to like, share and subscribe. Bye bye.